Hello, my name is Chris Loberg. I'm here to talk about the Tektronix DPO 70000SX oscilloscope. This is a powerful 70 gigahertz oscilloscope, and this video is going to show you how simple it is and accurate for using UltraSync on a 2-unit system. So let's begin by powering on the first unit, and I'll walk you through the configuration and some measurements that will confirm the tight synchronization capability between these two systems. While the unit is powering on, we're going to take a tour at the rear end of the two instruments to show you how the UltraSync cable is connected. Here we are at the rear of the instrument, and we're looking at the UltraSync cable. This cable is able to connect both the master extension on the bottom to the top unit, which is called the extension scope, and together they make a 2-channel 70 gigahertz oscilloscope. Now let's talk about the cable. This is a 3-cable set, starting out with the first cable I'm showing here, which is the PCI Express Gen 2 cable. This is for waveform and data cable connections available on the scope. And now I'm looking at the clock signal, and the clock signal runs from the two instruments to make sure that the clock is working correctly from the sample clock on the master unit. And together, this cable set provides a complete configuration for a 2-channel 70 gigahertz oscilloscope that can be scaled up to a 4-channel 70 gigahertz oscilloscope. All right, we're back to the front of the instrument, and you see I've powered on the master unit. The configuration menu comes up indicating that it is the master unit. But before I power on the second one, you'll note that it's looking for its extension unit, hasn't seen it yet. It'll automatically identify that once I power on the extension unit. So let's go ahead and do that now. As you can see, when we launch the other unit, it automatically identifies itself as an extension, and then the default configuration is displayed. It can be changed from a 2-channel 70 to a 4-channel 33. If no changes are made, it will go into launching TechScope and default to a 2-channel 70 gigahertz configuration. Now we'll go to part 2, where we're going to look at skew stability measurements on the DPO 70000SX. To perform these measurements, we've got the two DPO 70000SXs in our lab, and we're connecting them via a splitter to an Anritsu sine wave generator. The Anritsu sine wave generator will generate a 65 gigahertz signal into the two scopes. Once we get this configured, I'm going to launch TechScope, and here we are looking at 2 channels running on our master unit. Channel 1's from the extension, channel 2's from the master. Both set at 70 gigahertz with 200 gigasample per second sample rate. Once we've got that up now, what I'd like to do then is use DPO Jet to measure the skew stability using a standard deviation number as an indicator. What we're going to look for is the standard deviation or difference in timing between the two channels on a skew measurement. Before I get started, I'd like to increase the record length of the scope to the maximum level and then launch DPO Jet. Here we've got DPO Jet. I'm choosing the skew measurement criteria, and I'm going to take a single acquisition. And here we are capturing the information showing the level of skew standard deviation with each one of these captures. And I'm going to look at the variation with a number of single acquisitions of multiple edges. And what you're seeing here is a standard deviation of nearly 120 to 121 femtoseconds. This is incredible for the performance of these two units over UltraSync, and is tighter than most monolithic instruments in terms of skew stability. The DPO 70000SX series oscilloscope is a powerful instrument that can be used in 2-channel or 4-channel configurations with minimal amounts of skew between the two instruments. Thank you for your time.